Hey, sorry for the delay. The delay there, everyone. Ryan asked, "Are gambling apps allowed for the competition?" So, yes, basically any app idea is allowed for the competition. It's open for all of you guys to, think out loud. If there's something that you would like to, yesterday someone asked in the Discord channel, are they allowed to do an idea for an app that they personally work in currently? It's open for everything: gambling, finance, signatures, whatever your heart desires, guys. If you have a good idea for an app that you think would be great on Tezos, or would be great in general, specifically if it could take care of, if it takes into account proof of stake, for example, it's not a must, but everything is open. So the world of this competition is your oyster. Do with it as you please. Use the framework that I put into the Discord channel as a guideline, and ask away either here or in Discord, or here while we're in the chat, or Discord in general, and I'll get back to you guys. I'd like to introduce you to Korney. He's the CTO and co-founder of MadFish.Solutions.
Hi all. Hi everyone.
Yep. And yeah, Korney, the floor is yours.
Yeah, thank you. Thank you very much for introduction. Yeah. So today I'm going to show you guys how to actually integrate the smart contract that you have developed with Anastasia into the UI. So today we will be working with the React framework. I understand that maybe not everybody has worked with it before, but I'll try to cover and to explain all the things we will be doing during this small lesson. So let me share one link with you so you can actually try to get the environment on your local machines, so you can follow the this tutorial with me together. So 1 second, please. Yeah. So I'll send the link here in the chat, and also I'll try to send the link into the Discord channel. Yeah, 1 sec. Yeah, it should be there. So basically, this is a test project I have prepared for starting our tutorial. It doesn't have much. It has only one button and one Tezos logo inside of it, but we'll try. Oh yeah, and also most importantly, it has all the required dependencies installed into, specified in the package JSON. So you will just need to run the yarn command only once, and you should have all the dependencies set up in place. Let me share my screen so I can, I can show you some of this magic. 1 sec. Yep, you should be seeing my Discord. Yeah, cool. Okay, so yeah, first of all, let me show you the structure of the project. It's basically a create React app template, which creates a very simple React application. And it can be started like this. Command yarn start. I'm not sure if it's visible. Yeah, it says I'm running one already. So yeah, let me kill this one. Yeah. So this is yarn start. Yeah. So this is our app. Let me bring it here. Yeah. So this is how it looks right now. It's a very basic application with the only connect wallet button and ability to change between the night theme and day theme. So yeah, that's it. And we will be trying to extend this UI with more advanced functionality to interact with the different FA12 tokens. So we will try to build a tool that will allow users to insert the smart contracts address and then get user balance for it, using your wallet. And also it will allow us to execute some actions, for example, transfer action. I think this should illustrate how actually how usually it happens to developers to interact with the smart contracts from the UI. Yeah, okay, yeah, I'll try to zoom my code, sure. I think we can start from installing all the required things into our environment. First of all, as you see, there is a button called Connect Wallet. That means that we will need some kind of wallet for it, right? Like we are lucky because we at MadFish.Solutions already developed one good wallet for interacting with the apps. It's called Tezos Wallet, and it can be installed via the following link. Let me send it over to you in the chat. One sec. Basically, Tezos Wallet looks like this. It's a main interface showing your XTZ balance. It also allows you to add tokens, and it even supports more than just displaying your Tezos address. It supports displaying your Tezos domains address. But that's something, we will try to cover later. So you should try installing it through the Chrome link, or there is also a version available for Firefox. You can find it. Yeah, sure. Can you see my screen normally right now? Okay. So this is like our main website. It has also links to Firefox, and great. Okay, let me make it smaller. So okay, so we have the following code structure right now. It's here we will store all our components. We have main component called app, which consists of some nested other components imported here. I personally like to use TypeScript because it provides more safety to your code due to more strongly typed version of JavaScript. And it allows you to catch more errors at the compile time. So what we will do, again, let's set up the wallet first. After you set up the wallet, you can actually get some test.XTZ for the future use. How to do it? Basically, there is a faucet from Tezos community called faucet.tzalpha.net. I also will share the link right now in the chat. One sec. So this faucet allows you to get some testnet XTZ, which you can use for different testing purposes. So how it's done? Basically, you're able to download, either copy this or download the JSON file. Let's download to desktop. And so you see this has some TZ account type of hash. And we can then import it into our wallet. So it can be done using import by pressing on the logo here and importing import account and then faucet file. After this, you can press select faucet file and select newly downloaded faucet file from your disk. After that, it's going to activate that account in the network, which may take a while. I think, it should take at least one block time. So it's about 1 minute to 30 seconds, something like that. Let's wait a bit, and then this account will pop up in our wallet. So again, we will be using Delphi testnet. It's important to note because we don't want to spend real money right now, right? We want just test our network, and we want to test all the stuff around the smart contracts, and we don't want to pay real money. Yeah, so this account has been activated, and now we see that we've got this number of ecstasy inside of it. This is great. I think that's pretty enough for us to start with. Yeah. So again, yeah, we have this UI, which we will be trying to improve over the course. Yeah. So over the course of the next hour. Basically, yeah, we also using here, as you can see, there are some already pre-built components. These pre-built components are called Chakra UI. It's basically a very minimalistic and quite easy to use components. Yeah, you can actually install in your any project. And yeah, I think it uses CSS and JS approach, which is basically when you write your CSS right in your JavaScript. Yeah, that should be fine. Okay, so what do we need to do? As we can see, there is a connect wallet button, but it doesn't do anything yet. So we need to try to make it work right now. For this, how basically wallets are connected to the D apps. There is a framework called Beacon SDK. Beacon SDK is a special framework designed for interoperability of wallets on the Tezos network, and it supports so-called TZIP-10 standard. What does it mean? TZIP-10 standard is a standard that describes how wallets should interact with the D apps, web-based D apps. And yeah, so they also have a website describing all their features and allowing you to actually test different features right from here from your browser when you have like Beacon extension installed. So they also have like their own wallet, but our Thanos wallet actually supports Beacon as well. Yeah, so you can try pressing here like request permissions. Yeah, but you should select network Daphne. Yeah, for some reason it says it's already connected. Okay, yeah, never mind. It seems, yeah, it's like part of my previous testing affects this behavior, but yeah, I will try to show how we can actually integrate the Beacon inside of our code. So yeah, like React, again, consists of components, mainly which can be either class or pure function, which is great. Yeah, we can just compose functions in a functional manner and build interfaces. In the last, I think, year, React framework has added a new way to manage state called hooks. And these hooks allow us to manage state in very reactive and, I would say, functional manner. That's why we'll try to create hooks for to actually support this connect wallet functionality. Yeah, so for this, let me create new file and call it Beacon, use Beacon. Yeah, so first of all, of course, we need React. And then we will also need a thingy called Taquito. I think Anastasia already showed you how to use Taquito for testing your smart contracts. It's already built into the truffle for Tezos. But when we use it like in the D, inside of the D app, we need to specifically install it into our package.json. And yeah, so this is the version I'm currently using. And if you clone the repo from the link I've sent, it should be specified there as well. So this version actually supports some advanced functionality, I mean, newer one, which allows you or developers to actually call the view methods of smart contracts. Because in Tezos, view methods that only return data, they don't change the state, These methods are intended to be called by a smart contract rather than by a user. However, it's going to change soon because like many developers need to obtain some calculated data from the storage. And as long as all the interfaces are specified mainly for methods, but not the storage itself, we would definitely need to try to call these view methods at some point. Yeah, so also we have a special adapter called Taquito Beacon Wallet. It's a special library that allows us to connect the Beacon SDK to our Taquito as a wallet provider. This is useful when you want to interact with the smart contracts and call and sign operations directly with your wallet, but when you don't want to specifically call the wallet, separately. So it provides like a unified interface for all of that. And what we also have here is like Beacon SDK itself with this version. Yeah, there is actually a second version came out today, but we're going to stick to the first version. It's not that different. It should give you like a general understanding of what's going on here. And yeah, I think yeah, we can continue with this. So yeah, let's import all the required packages. Yeah, we have the Beacon wallet. We also have to include Tezos toolkit from Taquito. And what we're going to do next is we want to describe the metadata of our D app. So our D app has to have some name. Let's call it FA12 direction D app. We can have some icon URL. It can be used for displaying the proper icon when user connects to your D app. And what we can also specify here is event handlers. So event handlers is something, it's like kind of a hook where you can subscribe to some kind of events from the Beacon SDK. So we can subscribe to permission request success. I'll explain a bit later what this means. Okay, I type here. So this handler should be called like this. Let's use any for now, because it can be really any type, and put some logging here. Oh, yeah, it should be in an object. Yeah, so next we have to initialize our Tezos toolkit by creating a new instance of that class. And what is required right now and wasn't required before, we have to provide an RPC URL. So RPC URL, RPC is basically the node you're trying to connect to in order to sign operations and push your transactions. And as long as we are using DelphiNet, and as long as there are several public nodes, I think we are going to use one of them. This is Giga node. It's one of the main nodes we are using right now in production because it's highly reliable, and yeah, we had no issues with it. So then after we created Tezos objects, Tezos toolkits, I mean Taquito basically, we can create new Beacon wallets. So, and provide it with options. So as long as we have, yeah, this is great. It's almost, yeah, we're almost done. So then we have to specifically indicate to Taquito that we are going to use Beacon wallet provider as our main provider right now. So we are just passing this wallet object to the method set wallet provider. As for the next steps, we are going to create the hook itself in order to provide the functionality to actually connect to the vault. Let's do it. So let's call this function use beacon. It's a general convention to call hooks using this use keyword. I mean, not keyword, but rather like prefix. And yeah, what it actually does. So it uses beacon. Yeah. So yeah, let's define let's define a connect methods. So a method that we are going to use in order to connect to our wallet, something that we need to call in order to trigger this connection. If we would write this like this, it won't work well because it would return every time this function called, it would return this new function. But we want to memorize it using the React internal function called use callback. It says that use callback is required 2 arguments, I guess. What this argument is basically dependency list, which indicates when we should recompute value of this callback. For example, if we had some kind of variable that or parameter here that we would depend on, we would need to add it here so that when this parameter changes, this callback function is created for it. Yeah, but right now I don't think we have any dependencies here. So we need to just write the code that does what we need. So yeah, it has to be async function because we are going to do some async action soon. Basically, what we are going to call right now is like the main method to connect to the wallet from the Beacon SDK. It's called request permissions. So this request permissions method actually tries to communicate to the wallet and ask it what is it allowed to do on this the app. So we have to provide some configuration on the permissions here because we want to specify the network we are on. It's network type Delphinet. So I have like automated imports here. So I think if you're using VS Code, you should have them too. So network type is exported from Beacon SDK, just in case you don't have this feature in your IDE. So you don't get confused. By the way, I will be sharing like the complete version of this app later today. So so if you even miss something, you will be able to take a look at the working example. So as for permission scope, we have to add several permission scopes. Basically, what permission scope is, it's a scope of permission we're allowing the app to operate on. So there are several of them, as you can see. When I put the spirit here, it shows that our app can request sign-in, it can request threshold, and it can request broadcasting operations. So we are going to ask for everything right now, just to simplify all the things. Yeah. So this is right now like the async action, and we have to await it because we are going to do one more step because we need to return from this use beacon hook a thing that indicates whether our wallet is already connected or not. So for this, we will create internal state. Here. So It stands for public key hash, which is basically user address. We can, yeah. So we can then use another hook called useState. UseState hook allows you to actually create some internal state inside of this function that will be memoized during the calls of this function. Yeah. So this state is going to be a string without no default value. So you can actually provide default value here and all this stuff, but we don't need it because we have to specifically know that we have an empty public key hash or user address in order to determine whether we are connected. So it's quite naive way of doing that, but I think it should illustrate how we can actually, manage this connection. So and after we requested permissions in this function, we have to set the actual user address. In order to set it, after the permission have been given to our app to interact with the wallet, it allows us to fetch it directly through the wallet API using the getPKH method. So after this, you should be good to go. And we have to return the connect method. So right now we can test this part. And let's return the actual private key hash, public key hash, sorry. And we can try using this function, using this hook inside our components. So we have like several pre-built components here. One of them is dashboard. How we can use this hook that we just built. We can import it. Okay. And then we have this connect method and this public key hash. So let me think. We can do the following. We can put the actual connect method to this button, to the config handler of connect wallet button, and we can specify that if there is no public key hash, then we display this button. Otherwise, we would display something else. Let's say some component called account info. So let's say it's a functional component with the age required. And it would return text object from the chakra. I guess, I should import it finally. It's from, and this text element would actually contain text your account, and then we can use another component from chakra called code. It's just also text type of element, but with some background. So I think it should, and I guess it uses monospaced font. That's why it's easier to distinguish address visually. So and we can actually put our PK edge here. We have to specify it in the function itself. And we can finally tell our dashboard component to display. Yeah, let's format this code, and yeah, so it says React is defined but never used. Yeah, we can actually remove it here. Yeah, so we have just created these dashboard components. Let's see how it looks. Let me just for some sanity clear all the local storage, reload the page. So this is how it looks. And let's press Connect Wallet. Yeah, as you can see right now, we've got this pop-up confirming the connection to our D app. You can see the list of the actual accounts I'm going to interact with. I can select another account. So I think on this one, I have some FA12 balance. Yeah, and as you can see, we've got this beautiful message saying that, yeah, my account is this one. It's actually this one account, KUML. Yeah. Okay. So, do you have any questions already, or yeah, or maybe I should continue? Okay. If there are no questions, I guess we can actually continue. Yeah. Great. So the next part would be, I think we can add some advanced UI, and the next thing we would like to add here is it would be great if we could actually interact with some smart contract or get its balance and do some real stuff with the blockchain, because we just only connected the wallet and that's it. One sec. Yeah. So let's add the divider. It's another component that we are going to just use to separate our UI elements in future. So it's automatically imported, and it looks like this, like a small line. I'm not sure if it's visible to you, but it visually just separates the content. And then I guess it would be great to create another component for inputting the FA12 contract address. This we will create a new file called contract address inputs, TSX, which means yeah, it's TypeScript for React. So for this we will import React, and we are going to export text. So it's going to be a type input props. It will be imported from Chakra UI. And yeah, so right now we are going to it says, yeah, we'll have to return. Yeah, I think we can even use mount. So we are going to use box element from the Chakra UI. It's you can treat it as a simple div element, which means it's just a basic block here. So it says it can find name. Yeah, sure, we can name it ourselves. And then what we are going to add here is we're going to add text element and it's going to be of the size of small and aligned to left and with some margin to bottom, I guess. It says contract address. Sure. Group. Input group is a basically component that allows you to create more advanced type of inputs. So it allows you to customize it, add some icons, some buttons to it. Yeah. So and that's why we can actually add another type of element here. It's called input left element, which is going to just provide the left element of our input. And we are going to import an icon for that. So there is a special package called Chakra UI icons with some already pre-built icons for you to use and think about it too much. So yeah, we have to provide children like this. Yeah, so it says that, yeah, we don't have the corresponding, yeah, like this. And so we have to provide our input itself. So yeah. And this input will inherit all the props we are trying to pass it down to it. Basically, this syntax is a spread operator. You should, if you ever worked with the TypeScript, yeah, you should know what it does. It basically takes the object props and applies all of its properties over this object input. Yeah, JSX and TSX makes it a bit abstract here, but yeah, I think it should be clear. If it's not, let me know. Yeah, sorry, I see one question. Can you publish it to GitHub? Yeah, I will be publishing it to GitHub after we finish this like small lesson. Actually, I sent the link to the Discord channel and to hop in chat with the link to the repo I'm currently using and where I'm trying to develop it. Okay, so let me try. Yeah, so actually we have this component ready. We have to import it here. Import it. We can try using our contract address input, and we can add it right here. So this input is going to accept our contract address. And then once we inputted the contract address, our app will try to fetch the storage of the contract and load it into our view, so we can observe how actually the storage of the contract we have just provided to it looks. That's why we are going to, yeah, we are going to add some more logic here on the dashboard component. As long as like this contract address input is main thing to our dashboard, we are going to store this logic right here. So for this, I think it's also, we can again use state hook. It's going to be string. We can actually provide some default value to it, so we won't type it every time we every time we try to test it. So yeah, let's do it this way. And it's going to be contract address, yeah, and set contract address is a function that will allow us to set value of this variable. Yeah. So for this, like our contract address input inherits all the properties of the regular input. That's why we have a regular onChange handler here. And inside of it, we can provide a callback which will fire on each change of our inputs. Basically, we can provide, so in the callback, we receive the event object from which we can extract the current value of the input. So it can be done using e.target.value. So after we extracted this value, we have to set it as a contract address and make it the same typos. And yeah, that should be it. So right now we have this contract address. But the problem with it can be, I mean, when you type it, it can happen that it's not a valid address, right? And we need to know how to actually validate that. So for this, I think we will create a util. Oh, yeah, we already have it because I prepared it beforehand. So we have like two utils. One is called validate Tezos address, and another one is called validate contract address. Basically, Tezos address, it validates any Tezos address, both contract and the usual TZ1, TZ2, TZ3 addresses. And validate contract address is specific to contracts because it checks that addresses starting with the KT1. If address starts with KT1, it means it's a contract. Yeah, it's almost always like that. So yeah, after we have this function, we can actually import it and provide some logic to add some validation, so we won't be doing extra stuff when the address is not valid. Okay, so for this, let's do use state, but this time with Boolean value, and it's going to be false by default. And let's call it contract valid. Set contract valid. And right now we can make use of interesting hook, which is called useEffect. UseEffect actually accepts, again, one callback and dependency list. And what it will do, it will try to execute the callback each time the dependency list changes. If you leave the dependency list of it empty, in that case, it will be only triggered once on the initial render of this component. Otherwise, if you provide, for example, pkh here, this callback will be triggered each time the pkh variable changes. But we are going to look at the contract address. As long as when it changes, we have to validate it. That's why we are going to add this code, set contract valid on each contract address change with the value of validate contract address of the contract address. Yeah, sounds good. So yeah, we have this variable that indicates whether our contract is valid right now. For this, we can, yeah, to get some visual feedback on this, we can actually try to provide property called isInvalid to our contract address input. It's like a property provided by Chakra again, so it's like UI framework that makes your life a lot easier. That's why I'm trying to show every example here using it, because you don't want to build all these custom styles and yeah, validation logic by yourself, but it's easier when it's already built for you. So yeah, if it's invalid, so we have like contract valid, it says is invalid, so we have to flip this Boolean value. Yeah, so yeah, so right now we should have this. So when we press connect, it will automatically pop up. So the only thing I'm not sure of why it doesn't show the actual value we have provided. Oh yeah, exactly. We forgot one important thing. We have forgotten to provide the actual contract value to the input, because we are actually setting it, but never reading it from our input. So let's put it here. Okay, yeah, we have it. As you can see, when I delete several characters, or even one, so it turns red. That means that our contract address is not valid, and that in that case we will not be performing any logic. So yeah, so let me think. Okay, what's next? Yeah, I think as next step we are going to add some logic in order to actually fetch some information when we've got a valid contract. Yes, so for this we can create several components that will render only when we have this variable contract valid set to true. Yeah, that's why, for example, we can get storage info as I said before. So let's do it. For this, we will create new component called contract storage info. Yeah, so I think we can. Yeah. It's again React functional component, some props, and yeah, and some logic, I guess, this time. So what it will receive as a prop is basically contract address, because we needed to actually get some information from the Tezos network on this contract. And yeah, we have to specify what type is string. And so it says, yeah, it's empty. Okay, so for this we can actually use our use beacon hook again, because use beacon, but we have to extend it a little bit. So this time we are going to just also provide Tezos object here. Yeah. So Tezos object. And using this, so basically this Tezos object is a Taquito toolkit, a Tezos toolkit from Taquito. And this will allow us to do some fetching the contracts storage a bit later. So yeah, I think we can, yeah. So we will make use of one hook that was provided already with this template. It already was written by me. It's basically, it's called use pending promise. What it does, it has like only two arguments. One is fetcher, which is the main argument here, and the first one, and optional argument called transformer, which allows you to transform your result as you wish. So what it basically does, it actually creates it returns fetching error and data. And what it means, it will allow us to fetch some data, and it will indicate while it's fetching whether there is an error and when we've got the actual data to our front end. How it works, it basically creates a use effect, which depends on fetcher and transformer. So if we change one of these like arguments, it will recompute the value, otherwise it will stay the same. So it will try to call the fetcher, get its value, and set the actual storage to that value. Or if it will catch an error, it will just set an error and return it here. Yeah, again, also indicating whether it's right now fetching or not. So we can show some preloader of the data. Yeah, so as for preloader, we already have it here. Yeah, and I think we can get back to our contract storage info component. So for this, we can create a new fetcher function, which should be wrapped into use callback. Because if you don't do this, it will create a new fetcher each time this component is rendered, and it's not something you want. You want it to be memoized according to the dependencies you provide. So this is going to be a sync function, which is going to call Tezos contract add. So this Tezos contract add is an Tezos API for fetching the contract to the UI, and actually it allows you then to interact with this contract. So we have to provide contract address here, and we can access storage. So storage is a method that is also returns promise of unknown because like storage can be of any type, and yeah, okay, I don't think we need this await here. And yeah, and then we have to provide our dependency list. So it's basically Tezos contract and contract address. After this, we can make use of our use pending promise hook. Okay, so let's use our fetcher. And as a transformer, we're going to use JSON stringify method. It's a built-in function into JavaScript, which allows you to stringify it into JSON. Because storage can be complex type, and we want to see it in more human-readable way. So yeah, we have fetching, we have data. Let's remap it to storage, and we have potentially error here. Yeah, let's return something from this component. So for this, so let's not show anything until we are definitely. So yeah, let's show the actual components when we are not fetching and when we've got either storage or error. In this case, we will show box. So a box of width full, and it should have some text as well to indicate what we are displaying here. Again, with some similar layout. Let's call it contract storage. And then this way, so it. Okay, so it says just support attributes. Okay. So yeah, text area. Let's make it into text area because like storage can be really big, and we want to see it in more, again, human readable way. So let's use text area for this. And is invalid. Let's say it will be highlighted with red if it's. Yeah, we don't have this just inverted, so yeah. And let's, yes, as long as we have preloader component already here in place. We can use it straight away. So let's just write that there will be a preloader. Yeah. Why is it? Yeah. Okay, and that's it. So we've got this component. Right now we need to integrate this component into our dashboard component. So as you can see, React is more about composing different components with different logic into one single application. So yeah, right now, in order to display it, as I said before, we have to actually take into account whether our contract is valid and whether we have contract address. I mean, we should have contract address when the contract is valid, but just to ensure that we are not trying to fetch something that could not exist. And yeah, let's put it this way: contract storage info. Yeah, it automatically imported, and let's move it this way. Okay, so it requires contract address as a main property. That's it. That should already work. So if we've done everything right, let's check it out. Yeah, as you can see, we've just seen preloader, and then we've got a storage. So just to ensure that it works with every contract we want, we can go to the better call def, and right now I will press something, then I will go to statistics, and there is statistics for FA12 tokens on the network. As we are on the DelphiNet, we have to go to this section, and we can actually copy any contract address we want and try our app, how it works with our contract address. So we can paste another address. As you can see, this value has changed. So we basically just fetch a new storage for another contract. And it's, as you can see, it's quite reactive. So when we change this field, it does it automatically. So if you use the React hooks properly, you can achieve this effect. Yeah. So yeah, I'll make a short pause here. If there are any questions, and maybe something isn't clear. No questions so far. Great. That should be clear to everyone. That's great. I hope so, at least. If it's not even clear, yeah, I will try to share. I will try to share all the code right after this session. So yeah, you will be able to play around with it yourself. Yeah, I guess no questions so far. So yeah, let's continue then extending our app. I think I've got like several things that on my mind that we can add here. Yeah, so basically what would be great here is to add also ability to transfer tokens. Yeah, and also that would be great to see user balance of FA12 token if it's a FA12 token, right? So yeah, let's create a component called contract balanced for. So it again starts same with importing the React library. Even if we don't use the React itself directly, it should be imported when you're writing JSX. So because it gets compiled that way, so it's actually used. You don't see it. Okay, so let's call contract balance info and React functional components, and again contract address. And yeah, let's provide public key hash as a required property here. Okay, so yeah, that should be it. So like again, this time we are going to use Tezos from use beacon, and we again have to create our new fetcher function to fetch the required data. And we say Tezos contract at contract address, and then we can, yeah, let's make it this way. Yeah. Sync function. And yeah, this is going to be contract object. So yeah, this contract object actually has views. Views is a special new tool created by Tikita library. I can show you a bit of it here. So it's called Lambda view. As I previously mentioned in Tezos, likely to Ethereum, view methods are actually required to have a callback. So they are designed in that way so that it's expected for view methods to be called by a contract. But in many cases, you actually need to call this view method and to see some internals of the contract or get the computed value, which was created by the contract designer. So that's why we are using this advanced feature right now. What it does, it basically allows you to call, let me make it bigger. It allows you to call the contract and call its view method using this way, contract.views.method name and some parameters and then .read. It uses a proxy contract under the hood, and that's why it dry runs the transaction on the Tezos node and then gets a result back. So yeah, it's more advanced technique, and soon it will be probably included into the Tezos core itself. I'm not sure. Yeah, but let's see. So in order to get the balance, we can just call get balance here. But you can see there is no suggestions because yeah, there is no way to get typings for arbitrary contracts. Okay, so we can get balance for public key hash of our account, and then we have to read it, and let's provide a catch function because, for example, if the contract doesn't have a record of your account, in that case it would return a simple error. So we should just return 0 here. Okay, I think that's it. This would be our fetcher function. And as for dependencies, I think we have to provide contract threads as dependency, and this one. Oh yeah, and Tezos as well. Tezos contract. Yeah, great. After this, we can again use our fetcher function. Use pending promise fetcher, and that's it. I think result has been returned in as a natural number, so yeah, should be okay. So for this, we get fetching again, and data, let's call it balance, and potentially there could be an error. So we could actually even copy this part of code from here. Yeah, and we have to import all the required for some reason it doesn't import text. Yeah. Balance, and preloader is preloader. Yeah, that's it. The only thing is that we have to use a little hack right now in order to actually use this Lambda preview feature. Because, for example, if you don't have a balance in your account, then it won't be possible to use this preview Lambda feature. However, there is a hack that allows us to bypass that limitation. I think it should be improved in the near future. I mean, it's quite cutting edge thingy in terms of Tezos development. But yeah, so there is a way to provide own sign provider, and this is what we are going to do. We are going to write like a signer, Lambda signer provider here that will allow us to sign all the Lambda view calls with it. So yeah. Actually, yeah, I think I have somewhere stored somewhere it's already written, so we don't spend too much time on it. Yeah, I see on the next screen. So yeah, there it is. Yeah. So this is a Lambda view signer class we just defined. It's just a hard-coded version of it for random account that has balance with its public key here. It doesn't allow you to actually sign anything, but it will use this public key hash and public key in order to preview the balance of other accounts. So we can write Lambda view signer, and that's it. So that should work right now. Yeah, and the last part left is to actually import our newly created contract balance info into our dashboard. And to do this, I create a new fragment. So yeah, it's not possible in React to return like several values because it's like JavaScript, right? You cannot just write two values without no separator. So there is a way to do it in React. It's called fragment. These parentheses, they allow you to create, return several components without wrapping them into another like tag or another component. So yeah, let's contract balance info. Price contract address and page. Yeah, I did some turn on, so 1 sec. Oh yeah, sure. Okay. So okay. Yeah, this should work right now. Oh yeah, we forgot to change the balance thingy to storage need to balance contract. Yeah. As you can see, I have a balance on this contract. By the way, yeah, I haven't added it even here because it's another instance of my wallet, but you can actually add a token to the tenant's wallet using this form by pasting the address, and you can even assign your own symbol to it, like whatever, and let's call it workshop token, and let's say it has 0 decimals, and we won't provide any icon URL. So as you can see, we have this number of tokens, and it's both returned here and in our wallet, and it can be even explored in the Better Call Dev as well. So we have this. Yeah. Okay, great. So as you can see, we're able to get the actual balance of account using using Taquito. And the last thing, but not least, I think today I would like to add here is probably not balance mention, transfer method. Transfer method, which will allow us to trigger transfer of if I want a token to another account straight from the UI. So it's basically like calling the method directly using Taquito. It's not a view method, it's a real method that like changes the state of the smart contract on the blockchain. So it will require confirmation from the wallet to perform that action. So let's stop here for a second. Maybe there are any other questions in terms of what we just did, on maybe on Lambda view or something else. So yeah, please feel free to ask them in chat. Okay. Yeah, as far as I see, there are no questions. So yeah, let's continue. The next thing, the next component we are going to create, as I said before, is going to be contract transfer form, sex. And this component is going to provide us a form that will allow us to specify the recipient and the amount you like to transact for this contract. Okay, it again starts with the React. Okay, it's always going to be like that. I should have created a snippet for all of this manual stuff, but yeah. Contracts transfer form. It's also a React function component. But again, I'm going to accept threads and public key hash. Sorry, I'm writing already weird things, so yeah, it's getting late. Okay, so for this, we will have to again use our Tezos object from use beacon. Okay, I see the reason somebody having an issue. Sorry. Did you? Okay, and so the next thing we will have to create a state for our amount input. It's going to be a string value that we will convert then to number, and to its basically our recipient. And next thingy would be whether we are action or not. So it means that whether our UI is blocked right now by some action or not. So this is going to be like this. Yeah. So I think we could actually try to build the UI first. So again, it's going to be box with a bit full with some text, and I will leave it on the input. Text is going to be size small, line left. Yeah, and then if we are not fetching, we are going to build to show something, and if we are, then we're going to show preloader. Number. Yeah, so the first thing that we are going to display is the recipient input. That means that we have to just write an input here and maybe add some placeholder. I personally like to use probably my address as a placeholder, just so it indicates what should be put there. Value should be our variable called to, and we can add on change handler to set to. That should be it. The next thing I think we'll add another input for amount, which will have not just amount, it will also feature the send button. So we can use input byte element to this, which is going to be button size small, and with some on-click handler, which we're going to provide later. And button is going to say transfer. And yeah, we have to add input itself. Input for our will be like type number. So we are going to provide number as amount. And yeah, target value. And yeah, of course, we shouldn't forget about the value itself. It's amount. Yeah, so we have this code written here, and yeah, it looks good. So yeah, I think we have to probably add some additional styling here. So okay. So right now we have to write our send handler. So when we press on this button, it will when we press on this button specified here, we will need to trigger an action to actually trigger the smart contract and send tokens from our address to another address specified in the first input. Great. So for this, we again will use callback. So let's call this function handle click callback, and this will be a sync function, I guess. Yeah, so what it will do, it will basically set fetching to true at the start, then set fetching to false, false to at the end of its execution. Yeah, and in the middle of this thingy, we can even write try block to handle all the potential errors we can hear. So for this time, so previously we used Taquito's contract API, but right now, as long as we are going to actually trigger wallet action, we have to use Taquito's wallet API instead of contract API. It's pretty the same, but the problem with it is that they are slightly different, and so if you have like type-ins here, I mean, they have similar methods, but like contract API works directly with the RPC you provide, while the wallet API works with the wallet you provide. So yeah, we can again extract contract at contract address, and after we extracted the contract, we can perform the operation to send our tokens from one account to another. So as long as we are taking this contract as an example, we can observe how it looks in, yeah, that is it, how its method signature looks here. So as you can see, transfer method has 3 parameters. It has from, to, and value. So basically, when you provide from, we should provide our wallet public key hash, so basically our user's address. Then on to, we should provide the recipient, and on value, yeah, we should provide amount where we try to transact. So in order to do that, we basically can write contract methods, And then, as we saw here, method is called transfer. Right, transfer, and then just provide all the required arguments. So public key hash, then it's 2, and then it's amount, but converted to number, I guess, would be the most usable way to do it. So then we have, so it's we form an operation, but in order to send it, we have to explicitly call send method. Yeah. After this, we get the operation object, transaction wallet operation, that we can actually await for information and do some code here. Let's say something like this. Yeah, oh, yeah, we actually need to await it, right? So, and as long as we written it in the try catch block, we can make some login here. It's not actually a good practice to do these kind of things. And finally, finally we can always do set fetching to false. So this is basically what we need. As long as it's not yet complaining that we have empty dependencies list. But in order to have everything working correctly, we have to provide as dependency all the things we use inside of this function. So it's first of all contract address, then public key hash, then we have amount, 2, and we have set fetching function, which is also a dependency for us right now. Oh yeah, and of course Tezos.wallet. And we have to handle this click inside of this button handler. Just provide it like this. Great. So this is it, I guess. Let's input this component here. It's the last component in our D app. Transfer form, which accepts again contract address. Okay, so this should work right now. Let's see what we've got. Yeah, I think we've got it. It doesn't look great, right? So we can add a little bit of styling just to make it perfect. Yes, something like this would be sufficient. Yeah, it's almost perfect. Okay, so right now we have a fully working D app that actually fetches data from the contract and receives its storage and displays it in this JSON stringified form, which can allow you to explore a little bit of Tezos ecosystem. You can try putting here different contracts, not only like FA12, but the thing is that balance fetching and transfer will only work for actually contracts that they have the corresponding method signatures. So yeah, we can try transferring to our another account. So basically, I have this account with this enormous amount of workshop tokens, and I have another account where I don't have any tokens at all. So I want to copy to clipboard this address and press transfer, so I can transfer 10 tokens to it. As you can see, this is the most exciting moment. This is the window where user should confirm his operations. Right now, it shows all the operations in the JSON form. So it might be a little bit tricky to the user to understand the actual implications of this transaction. But tomorrow we will be releasing a new version of Tezos wallet, which will actually show you how much you are going to spend, or what tokens, and how much you're going to spend of XTZ. So yeah, so we confirm it, and we see this operation broadcasted message from Beacon SDK. So we see this operation hash. We can copy it. We can even open it in Explorer. Here you can see we still have spinning preloader because we specifically are waiting for one confirmation on Tezos network. So once the confirmation is there, this preloader should disappear, and then yeah. So we've got this alert, and I press OK, and yeah, that's it. So we can explore this operation on the block explorer. As you can see, yeah, it doesn't show the actual token transfers, but I think better call dev should do it. The transfer, yeah, and as you can see, it calls transfer method, and it changes ledger property of storage of my account and of another account. So yeah, that's it. Basically, what we just saw is calling contract straight from the UI and making changes to the blockchain directly from it. Great. So if you have any questions right now, you can ask. I think that's it from my side. I will be sharing this repo right now with you guys. I think I can actually push this to a separate, I mean, even maybe not separate, but in this branch. Check. Yeah, I think we can. So you can play around with it yourself. Oh, yeah, I have it here. Okay. Yeah, it's pushed. So yeah, you should be able to play around. Great. Okay, so I see one question. What if we have scenario that we need to transfer funds from our account to another account, then we refresh the web page prior to get any confirmation? Is everything going to be all right because the wallet? Yeah. So basically, when you press confirm button on your wallet, wallet handles all the transaction transmission and to the network, and after that, you actually will see this transaction in both your wallet and the blockchain explorer. Yeah. So there is no need to wait until the DApp will answer like that it's already confirmed or something like that. Yeah. So wallet handles all the cases. Great. Sorry, Alex, I can hear you for some reason. Okay. Yeah, I can hear you, Alex, as well. No, if I see another question, like yeah, if you deploy this to production, you probably distribute it as a browser extension or something similar. No, actually, you can. I just created a web application, so it can be just a usual website. Like if you ever interacted with the Ethereum web applications, for example, it will be just the same. So Tezos Wallet, in this case, works very similar to MetaMask Wallet, allowing you to interact with it. Yeah. So the only part that is going to be a Chrome extension or a browser extension is the wallet itself. But right now with this Beacon SDK, it even allows you to interact with the apps using your mobile phone. So if you have installed a wallet that supports this standard and you scan the QR code, you will be able to actually interact and sign transactions from your phone that are requested by a web app on your desktop device. So this is great, and this is I'm pretty sure that it's going to change all the things on Tezos soon. Yeah. Sorry, we cannot hear you still. Yeah. So basically, yeah, we can interact, and that's why when you first we had this connect button on our the app, it's actually what it does. It requests permissions first. So first, when you first log into the D app on any web page, it will ask first permission to do something, and you have to be careful, yeah, to read what it's asked to do, and then. Yeah, so then you can make your own decision whether to interact with it or not. So yeah, it's actually the same. Oh, and we can, right. Yeah, so then you can make your own decision.
Can you guys hear me now?
Yeah. Yeah, we can.
Oh, okay, great. Finally. I had to exit completely from Hopin and then basically come back in. Korney and Anastasia, thank you so much for tonight's evening of Tezos token programming. For everyone with us here, are there any questions regarding the competition and the Bitcoin Suisse certificates? They are extraordinarily nice, extremely nice, surprisingly extremely nice, where they even have their own custom Bitcoin Suisse paper holder. That's going to show up backwards for you guys. But yeah. So any questions regarding the competition? Korney, if there was a Ukrainian CBDC coming out soon, then we can make some of these for paper notes and make them actual currency.
Yeah, sure.
Yeah, then we could have one paper note that is backed up by one Ukrainian CBDC, and we've gone all the way full string back to cash.
Yeah, sure. That's a great idea.
just for giggles. All right, everybody. If you've got any more questions about the competition, please use the Discord chat. I'll be there to answer any questions. And keep in mind, they should be turned in tomorrow. There's no theoretical deadline before the course, after the course. Everything is fair game. If you think it's a good idea for a token and a platform, go ahead and write up your proposal for it and send it in. I guess send it in to contact@tezos.co.il, and we'll look it over as a group of 5. And yeah, work hard. Kick butts. We'll see you tomorrow.
Cool. Yeah. Bye.
Bye.
Thank you very much.